All right, hi everybody, how you doing? So we're moving on. We're gonna be solving Newton's questions. All right, this is 12.3. This is what I went through with periods 1 through 4 on Thursday the 3rd. So here's this question. Go ahead and pause it. I'll read it real quickly. Bubba's pushing on his car that is stalled out. Mass of the car is 300 kilograms, moving at 1.5 meters per second squared. Concrete has a coefficient of 1. And then how much force is Bubba pushing with? So when solving out these questions, okay, I want to break this down to 3 easy steps to follow. When I say easy, you know, it's physics easy, but it's easy steps to follow, okay, and help solving these questions out. Now, if you have not yet watched the free body diagram video yet, this first step might be an issue. So steps to solve. Give you a little heavy-handed hint. Step number 1 is draw free body diagram. Okay, so that is our first step to this. Draw our FBD. So in this situation, we have Bubba pushing on a car. So I can kind of draw the car as a square because it's an easy surface. And then I always add these extra lines to kind of represent the surface it's on. So all the forces acting on the car are the following. We have weight pulling straight down. It's on a surface, so there's a force normal. Remember, force normal is perpendicular to your surface. And then in this question, it states it's moving at an acceleration of 1.5 meters per second squared. Well, this 1.5 is positive, so it's kind of safe to assume that there's a force pushed towards the right. And also, there's this coefficient of friction, which means there has to be some frictional force. Well, friction is a resistive force, goes against your motion, so we're going to have a force of friction, fancy F, K, towards the left. So there's step 1, showing all the forces acting on this object. Step 2 is your summation of forces X and Y. Okay, so we're going to look at all the summation of forces in the X and Y axis. So what this all really is using is, okay, is Newton's second law, summation of forces equals ma. We're going to use this equation, but we're going to use it once to the X. So say force in the X and summation of forces in the Y. So all the forces acting in the X-axis equals the mass times the acceleration in the X. All the forces acting in the Y equals mass times the acceleration in the Y. So these are acceleration X, acceleration Y. So to do this, I'm going to leave this MA part alone for right now. Let's focus on this. So let's say, okay, what are all the forces in the X-axis? Let's put it into an algebraic form. Well, basically saying is, okay, in my free body diagram, I have forces acting in the X, I have forces acting in the Y. Let's put that into equation form. So force pushes off to the right, so that's a positive. So I say force, push. Friction's to the left, so that's negative. So minus force, friction, K. And do the same thing for the y-axis. Normal's up, positive, weight down, negative. So force, normal, minus weight. Bada bing, bada boom. Step 2 is done. So this brings us to the third step, and this is solve. Okay? So basically, what this question is asking, solve it out. That's why this step of the free body diagram and this step of summation of forces is really important, because now, for my solving step, it's pretty straightforward. I need to solve for force push. How do I know that? How much force is Bubba pushing? Force, push. Okay? So taking this equation, let's write in the x-axis. So I have force, push equals ma plus friction. Because this was minus here, add to the other side, makes it positive. So let's get going. So force, push is equal to 1,500 times 1.5, mass acceleration, plus. Now we do have to take a little bit of a pause though. We don't outright know what friction is. Okay, we have our friction equation. Friction is equal to mu force normal. Well, mu, I know, it's 1. Force normal, don't know that right away, but if I come over in the y-axis, hey, look, I have force normal in the question. So let's take a look at this. Okay, So let's analyze the forces acting in the y-axis. Well, in this question, it does not state anywhere that this vehicle is moving vertically up or down. Okay? So it's safe to assume that the acceleration is going to be 0. It's not being lifted up, it's not being pushed down in the y-axis. So my force normal is equal to weight. Okay, really didn't really do too much, but oh wait, I have a weight equation. Weight is equal to mass times gravity. Oh, I know the mass, I know gravity. So, weight equals mass times gravity, mass 1500, weight 9.8, multiply and you get 14,700 newtons. What this is basically saying is the car has a weight, so how much force due to gravity is being pushed down is this. The ground, therefore, is also applying the same amount of force, but up. Force normal is equal to weight. So I could take this number and plug it into my friction equation here. So I have friction is equal to 1, coefficient of friction is 1, times 14,700. That gives me 14,700 newtons. So therefore, Bubba, when I multiply 90 together, is applying a force of 16,950 newtons. Okay, so I went through that kind of quickly, but it's a pretty straightforward situation. If you want more help, rewatch this. Step 1, if you're drawing a free body diagram, is really important. Step 2 is also really important because then it helps solve for step 3 a lot easier. All right, that's all I got for you kiddos. Have a good one.